So hello friends, today we are starting with the model 1 of optimization technique. So this is very simple and quite easy module, okay, in which there are only three major topics. First one is partial differential, second one is gradient of factor valued function or matrices, and the last one is multivariate Taylor series, okay. So this is, you might be familiar with this, okay. Now moving to the first topic, that is function of several variable. What is function of several variable means? Function of several variable, as the name suggests, function which contains the several variable. See, as the example contains the variable x and y, there are two variable x and y, so it is function containing the several variable. Then moving next is the differentiation. You might be familiar with this differentiation. It measures the rate of change of slope of the curve, okay. So dy by dx is equals to f dash of x, okay, no need to elaborate much about it. Next is partial differentiation. See, partial differentiation is used when we have function which containing more than one variable, and differentiation is simply used when we have function of single variable, okay. So don't get confused, it's quite simple, okay. See here the example, z is equals to f of x and y, here two variables, so we will use partial differentiation, okay. Further you have to remember these two simplification, okay. First one is dou square f by 2x1 square is equals to dou by 2x1 into dou f by 2x1. Second one is dou square f by 2x1 2x2 is equals to dou by 2x1 into dou f by 2x2. Just remember this, okay. Now see the next, total derivative of z. So what is total derivative of z? Suppose the example given it is z is equals to f of x1 x2, which further depends on t. Let's suppose t, okay. Now how to find this dz by dt? So to find dz by dt, you should go stepwise. How? You should first find dou z by dou x1, then into dou x1 by dou t, okay, plus dou z by dou x2 into dou x2 by dou t, okay. So like this you need to find this, okay. So this is called as total derivative of z. Alright, then move to the next, basic rule of partial differentiation. So the first one is product rule, second one is sum rule, and the third one is important chain rule, okay. What is chain rule? Dou by dou x of f of g of x is equals to dou by dou x of g of f of x. You can write it like this or this, okay, both are the same things. And then which is equals to dou g by dou f into dou f by dou x. Just remember it, we will see a question on it, okay. Let's move to the question. First one is, we will be providing here with the function which depends on variable x1 and x2 as x1 square plus 2x2 square, where x1 is equals to sin t and x2 is equals to cos t, alright. So we need to find df by dt. How to find df by dt? The same formula which we have seen here, we have to apply now, okay. So the function f which depends on x1 and x2, further this x1 and x2 depends on the function t, means variable t, okay. So this same can be written as f depends on x1 and x2. This x1 and x2 depends on t. So this like this you can write, okay. Now you have to find df by dt. So df by dt is equals to what? As I told you, you have to move stepwise. So dou f by dou x1 into dou x1 by dou t, dou f by dou x2 into dou x2 by dou t. Simple. Now find the partial differentiation of this function separately and put it the values here. You will get all the answers, okay. I hope it's clear. Now let's move to the next topic. Next topic is gradient of factor valued function. No need to worry more about it. Just remember the Jacobian concept here. What is Jacobian concept here? Jacobian is simply a column matrix which contains the function 1x, function 2x up to function mx. Okay. Let's see with an example. You will get to understand it more clearly. Here y1 is equals to minus 2x1 plus x2, y2 is equals to x1 plus x2. You have to find the Jacobian determinant of j is equals to 3, okay. So y1 is equals to minus 2x1 plus x2, y2 is equals to x1 plus x2. See here the function with two variables given, so you need to derive the Jacobian matrices with the two column, okay. One is for x1 and second is for x2. Let's see how to derive. First you need to write dou y1 by dou x1, dou y1 by dou x1. Then next in next column dou y1 by dou x2. dou y1 by dou x2. So column 1, column 2, okay. Likewise, dou y2 by dou x1 and dou y2 by dou x2 here, okay. Now find the values of this partial differentiation separately. Then separate all the values in this Jacobian like minus 2, 1, 1, 1. Now solve this determinant, you will get minus 3. How minus 3 will be converted to 3? Because it's a what? Modular. So it will be converted to positive, okay. I hope it's clear. Let's move to the next question. See, a function h r to r is given such that h of t is equals to f of g of t with f from r of order 2 to r of order 1 and g to r of order 1 to r of order 2 and f of x is equals to given as e raised to the power x1 square x2 square and x is given as column matrix x1 x2 and gt is equals to t square sin t square cos t. See, here you can note a point as, see, if a function f from order 2 to 1 is given, so if you differentiate this f partially, then this order will reverse. Like this will come to r from 1 to 2, okay. Likewise, this also 1 to 2 is given, so 2 to 1 it will become. So same it is written, if function given 2 cross 3, then the partial differentiation of the function is 3 cross 2, okay. Likewise, you can solve the question. Similarly, this all is written. Decided gradient is computed by chain rule. So this is the function given in the question. You need to find its differentiation. So differentiation of h with respect to t. So dh by dt is equals to dou f by dou x into dou x by dou t, according to the formula which I have shown you in this page, where it is here. So according to this formula, you need to derive this, okay. Now, since x is having the two variable x1 and x2, so you need to write it as dou f by dou x1 dou f by dou x2 into dou x by dou t. How should you write this? Dou x1 by dou t dou x2 by dou t, because x1 and x2 is a column matrix, okay. So you have to write it as column matrix, and you have to multiply dou f x1 into dou x1 by dou t plus dou f by dou x2 into dou x2 by dou t, okay. So this you will get, and this is the formula you will apply further, okay. Now you have to differentiate partially this function with respect to x1, differentiate this function with respect to t, differentiate with respect to x2, and differentiate with respect to t, okay. So how to do it, okay. So let's see. F is the function with you have to differentiate with respect to x1. So f is given as e raised to power x1 square x2 square. So e raised to power, the differentiation of e raised to power x is e raised to power x itself. So e raised to power x1 square x2 square, you have to differentiate it with respect to x1. So 2x1 into x2 square will further come, because it's a chain differentiation. So 2x1 x2 square. Similarly, dou x1 by dou t, how to differentiate it? Here with respect to t, if you differentiate, here also you have to find differentiate it with multiplication rule, okay. So first differentiate this to t square, so 2t into sin t, plus differentiate this sin t, so cos t into t square, okay. So same it is written here, cos t into t square plus 2t into sin t. Similarly, you have to differentiate this also. So this value you need to put in this formula. So after this, putting this value in this formula, you will get all this simplification value. Just simplify it, you will get this result, okay. I hope I am clear. And now moving next to the, see, matrix with respect to vector, that is gradient of matrix with respect to vector, and we will see here all the three, okay. Gradient of vector with respect to matrices also we will see here. Gradient of matrices with respect to matrices also we can see here, okay, because it does not have any formula, just a step you need to follow, which I will tell you. See the example here. Consider the function L is equals to half e square is equals to half et, where e is equals to y minus ax. See, this L is the function of e is again the function of x. So most probably you have to find this dl with respect to x. See, dl is dl by dx you have to find. Okay, so how to find this dl by dx? See, the same I have told you, you have to move part wise. So dou l by dou e into dou e by dou x. So this is dou l by dou e into dou e by dou x. How to find dou l by dou e? You have to find dou L by dou E. So you have to differentiate this with respect to E. So dou L by dou E is equals to, see here, that is half E square. It has the standard differentiation here. Okay. So you just need to remember it and put it here. Okay. So E raised power T that belongs to a relation of order 1 cross M, and the differentiation of E partially with respect to X is what? Differentiation of E partially with respect to X is here minus A, because here is no X term, so it will become 0 minus A into 1, so minus A. So minus A. You need to multiply this and this. So e raised power T minus A. Now E can be written as y minus AX. So minus E y minus AX raised power T into A. So this will be the answer of the question. Okay. So simple only. You just remember this concept. What is the differentiation of half E square? Okay. So moving to the next note, we have gradient of f vector with respect to matrix X can be given as dou f by dou x is equals to dou f by dou x naught, dou f by dou x2, dou f by dou x3, and dou f by dou x1. Okay, so here also you can notice that this x1 should be flipped with this h2. So x2 will come here, x1 will come here. Okay, so next note is, if y is equals to y0, y1, y2, y3 and x is equal to x0, x1, x2, x3, then gradient of dy by dx, here it is two matrix. So matrix with respect to matrix, what you will get? So dou y0 by dou x0, dou y1 by dou x0, dou y2 by dou x0, dou y3 by dou x0, like that only you have to proceed. But take the note that this x1, x2 will be flipped. So here x1 should come, but it's not there. It's x2 is here. Okay. So this is flipped. So just keep this in your mind, and all is same as a matrix. Okay. So let's see a question over here. So discuss the gradient of vector with respect to matrix. What is gradient of vector with respect to matrix? Let's see that. Let we are having f is equals to a of x, where f belongs to relation of order m, a belongs to relation of order m cross n, and so it's a m cross n matrix, and x belongs to relation n. Okay, so we want to compute dou f by dou a for finding the gradient of vector with respect to matrix. Okay, we need to find dou f by dou a. Okay, so let's see how to find this. Step 1 is to understand the function. What the function is f is equals to ax. Okay, so each component of f is like f of I is equals to summation of a of ij x of j, because it's a matrix. So a of ij order, and x is j, because x is equals to n order only. So x is equals to j. Okay, m is I and n is j. So n is here, so x will come with j. Okay, so ai and x, so its answer is ai and x. So f is equals to a of x. Okay, so step 2 is gradient definition. What is the gradient mean? So gradient means we define gradient of a vector f with respect to a matrix A as, this is the definition of gradient. Okay, let's see what's the gradient is. It's a column matrix of f1 dou f1 by dou a, dou f2 by dou a, up to dou fm by dou a. Okay, which belongs to relation m cross order m dot n. Okay, so each row is a row vector of partial derivative of a scalar fi with respect to every element in a matrix A. So it's a row vector. So dou f1 by dou a is a row vector. Okay, let's see how it's a row vector. Okay, compute dou fi by dou a. It's a general of this dou f1 by dou a. So we are generalized here over taking the value I. Okay, so f of I is equals to aix. Only the ith row of x affect fi, because only ith I is here. Here also I, so no j is here, so only I will affect I. So ith row of a affect fi. Thus dou fi by dou I is equals to x of t. This is transpose. So x transpose of x, okay, of that, and that belongs to relation 1 cross n, okay. So next is dou fi by dou a ki, that is 0 and 0 transpose for all k is not belongs to I. For all that k is not belongs to I, that is k is not equal to I, this will be the value, okay. So we get what? Dou f of dou fi by dou a is equals to 0t, and somewhere in the middle we will get the xt row, okay, and then last ot, okay. So the xt is the ith block row, okay. Any ith blocked row can be xt, okay. Then finally we are doing the stack of all dou f I by dou x. So that is equals to dou f by dou a is equals to dou f I by dou a, dou f2 by dou a, and up to dou f m by dou a, okay. That belongs to relation m cross m dot n, okay. So at last what we'll do, f is equals to ax, then gradient of f belongs to relation of order m with respect to matrix A belongs to relation of order m cross n, and that is dou f by dou a is equals to xt 0 0 0 0 0, okay. So see here, every diagonal will be filled with this xt 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 xt, okay, and every non-diagonal element will filled with 0. So according to this definition, every non-diagonal element is 0 and every diagonal element is xt, okay. So likewise you have to do it, every diagonal element is xt and non-diagonal element is 0. So it's a block diagonal matrix with xt repeated along the diagonal block. So this is the answer for this first part of the question. Discuss the gradient of vector with respect to matrix. Same you have to paste in your exam. Now let's see the second part. Obtain the gradient of vector f is equals to e raised to the power x0 x1, e raised to the power x2 x3 with respect to matrix x is equals to x0 x1 x2 x3, okay. Let's see how to proceed for that. See here, f is equals to 2 e it has, so let's consider this as a, this consider as b, okay. Same we did here, we considered this as a, where it is, we consider one as a and consider second as b, okay. So it's a and b and we need to differentiate it. Since we are having the formula of vector with respect to matrices as dou f by dou x is equals to dou f by dou a by dou x naught, here it is the formula, same you have to apply there, okay. This, so same you have to apply here. So putting the formula dou f by dou f ab by dou x naught, dou f ab by dou x2, dou f ab by dou x1, dou f ab by dou x3. Now compute all these values separately, that is dou a by dou x naught. So what the value we will get for dou a by dou x naught, how to compute? See, dou a by dou x naught, so this is a, so this is a and this is b, okay. So let's see what we will get for a. Dou a by dou x naught e raised power x naught into x1. So dou a by dou x naught we will get as e raised power x naught x1 into differentiation of x naught is 1, so x1 you will get. So e raised power x naught x1 into x1 you will get. So here e raised power x naught x1 into x1. So let's see for b dou x naught b. Here no x naught term is there. So if you do, then it will be become 0, okay. So you will be writing 0 for this term. Wait, this term will become 0, okay. So likewise you have to compute all the values for this a and b and put it over here in this matrices and you will get this answer, okay. I hope you understand what you have to do in this question. Now move to the next note, that is gradient of vector with respect to matrices. Let's see the vector given here as y is equals to ab, where ab are the function containing x0 x1 x2 x3, okay. Then how to write it? See, dou u by dou v is equals to this a b, this dou a by dou x naught, dou b by dou x naught, you write the both the term in a single bracket or single place, okay. Dou a by dou x naught, dou b by dou x naught, dou a by dou x2, dou b by dou x2. How to relate it with the previous formula? Let's see. Previously it was dou f by dou x naught. Now you are having x and y, two terms you are having, okay. So if you are having, sorry, a and b, so both a and b you have to write here only, okay. So dou a by dou x naught, dou b by dou x naught, then dou a by dou b, dou x2 by dou b. If only one variable will be there, then you should write it like dou f by dou x naught, dou f by dou x2, but here it's two variables, so dou a by dou x naught, dou b by dou x naught. I hope you understand how to do it, and just like that you relate and remember this formula. Now let's see the question over there. Calculate gradient of a vector with respect to matrices. But the matrix is given as x is equals to x naught x1 x2 x3, and the vector is given as y is equals to x naught sine x1 square x2 cos x3 square x naught. Okay, so this is important, and let's see this as a, let's mark this part as b. Okay, this is b. So likewise you have to do separate differential for this a and b. If you want to differentiate this a, then take the differentiation with partial differentiation with respect to x1 and x2, and partial differentiation with respect to x3 and x0 for this b. Okay, so likewise you find all the partial differentiation, a for a, dou a by dou x1, dou b by dou x1, dou a by dou x2, dou b by dou x2, then dou a by dou x3, dou b by dou x3, and dou a by dou x0, dou b by dou x0. Find separately for this all and put the value over here. You will get this answer. Okay, so let's move to the next question. Find the gradient of matrice with respect to matrices. So for the matrix with respect to matrix gradient, we saw already the formula over here. So this formula you have to apply. Okay, this formula you have to apply here. How to solve it? First write the formula. Okay, then find all the individual values. Dou y naught by dou x naught. See here the y is this. So y naught will become sine x naught plus 2x1, y1 will become 2x1 plus x3, y2 will become 2x naught plus x2, and y3 will become cos 2x2 plus x3. Okay, so just take all the individual partial differential here, and after calculating individual partial differentiation, put in the value for the formula. Okay, and you will get the result. And now let's move to the last topic of this chapter, that is Taylor series for multivariable. Okay, so this series you have to remember, and it's for I guess it's for third order. Okay, because first is here, second is here, third is here, so it's for third order. Okay, so what is Taylor series? Taylor series you can write it as fxy is equals to fab. Ab is the variable, and that is equals to x minus a is that a, and b is equals to y minus b. Like this also you can see in the questions. How to remember it? F of ab plus 1 upon 1 factorial x minus a fx ab plus y minus b fy ab. So for the formula trick, just remember the a plus b whole square. What you do in a plus b whole square? That is a square plus b square plus 2ab. Same you have to apply here also. Okay, see here it is 1, so you will do it x minus a fx, okay, ab plus y minus b. This is single term and this is other single term. Okay, so x minus a fx ab, y minus b fy ab. Now see 2, so seeing this 2, you should remember this formula, x a plus b whole square. Okay, and seeing this 3, you should remember this formula. Okay, likewise you have to solve, like here it is a square, so x minus a square, and fxx, because x is square, so xx will be becoming 2 times. Okay, so fxx ab plus b square, so b is y, so y minus b square fyy ab plus 2ab, so 2a is x minus a, b is y minus b, and this is default term, that is xy, because here is x, here is y, so fxy ab. Okay, likewise for 3 factorial, 1 by 3 factorial, remember this a plus b whole cube, that is equals to a cube, that is x minus a cube fxxx, because x is cube, so triple x will come here, ab plus y minus b whole cube, because b is cube, so y minus b whole cube f triple y, because y cube, so f triple y ab plus 3 a square b, so 3 a is x minus a square and b is y minus b f x x y, because x is square, so x x y ab plus 3 a b square, so 3 x minus a b square is what, y minus b square, and x comes only once and y comes 2 times, that is y square, so y 2 times ab, plus likewise only you have to proceed So in exam you will be get only up to third term, no need to learn for the fourth term. So this is the Taylor series you have to remember. Okay, then let's move for the question of Taylor series. Find the Taylor series expansion of the function f(x,y) is equals to x square y square plus 2x square y plus 3xy square in power of x plus 2 and y minus 1. See, find the value of a from here. What the value of a you will get? X plus 2 is equals to 0 if you do. X plus 2 is equals to 0 if you do. Then you will get the value of a is 2. Okay. So the value of a is 2 and the value of b is 1 likewise. Okay. Sorry, it's plus. So the value of a is minus 2. Okay. So the value of a is minus 2 and value of b is 1. So given function xy as this and ab value you got. Now you have to partial differentiation of how till second term you have to solve. So you have to find the partial differentiation of this f and y separately, then xx and yy, and then xy. See, write the formula first for the Taylor series. Okay, if you write the Taylor series first, then you need you will be knowing what till what order you have to differentiate. Okay, so fx means dou f by dou x. Okay, fy means dou f by dou y. Okay, so just solve it and put the value of this minus 2. A is minus 2 and b is my 1. So ab. So just put the value in this equation, then you will get all the result. Now after getting this all value, just put the same value in this formula and you will get the expansion. Okay, you can solve also for further expansion or you can leave also. Let's see the second question. Expand x raised to power y at 1 up to first degree term. So for this, first write the Taylor series expansion for first degree term. The question will become easy for you. So this is the Taylor series expansion for first degree term. Okay. So the value of a is 1, the value of b is 1. You need to just partial differentiate it, this function x raised to power y with respect to x once with respect to y. Okay. With respect to x, if you do, then what it will come? This will become constant. So it will be a yx raised to power y minus 1 like this. And for y, this will become constant. So x raised to the power y and then log x. Okay, this one. Now put the value of x and y separately. Okay, the value of x is 1, the value of y is 1. Just put the value and put the same value to this equation. You will get the answer. Okay, I hope it's simple. Let's move to the third question. Expand e raised to power x log 1 plus y in the power series of x and y up to term of third degree. So third degree expansion of Taylor series you first write here. Okay, it's not written here, but you should write the third degree Taylor series expansion. Okay, then seeing to this expression, whatever value you have to find, just find the value first. Okay, see like fx, fy, f double x, f double y, fxy, f triple x, f triple y, fxxy, fxyy. Likewise, you find the formula for all. Like for the partial differentiation of f with respect to x, what the value? E raised to power x log 1 plus y, it will be same because e raised to power x with respect to x only you are doing, so it will be same. The differentiation of e raised to power x is e raised to power x only. Okay, so it will be same. So the value for x is 0 and the value for y is also 0. So just put the value, you will get the answer. Result is 0. Then partial differentiation of f with respect to y. So what you will get here? E raised to power x log 1 plus y. Okay, so see, log 1 plus y will become e raised to power x 1 upon 1 plus y because log a differentiation is 1 by a. So likewise, e raised to power x 1 upon 1 plus y. So put the values of x and y separately, you will get the result as 1. Likewise, you have to solve for double x. For double x, just differentiate this with respect to x now. So for differentiating this with respect to x, you will get the same result over here. Okay, the same result you will get. So it's 0. For differentiating double y, take this and differentiate it with respect to y. You will get minus 1. Okay. Likewise, you see all, and just after getting all the results, put in the value or in the equation and you will get the final result at this. Okay, I hope it's clear. Now let's move for the fourth question. You have to expand e raised power x cos y about 0 and pi by 2. The value of x or a is 0, the value of y or a is pi by 2. Okay, up to third degree term. So first write the third degree term, and then likewise you first write the third degree term of Taylor series, and then individually you solve all the partial differentiation. Okay, so you will get all the results. That if you want to find fx, then dou f by dou x. What is dou f by dou x? Likewise, which I have told you, dou f by dou x is equals of e raised power x cos y is equals to e raised power x cos y. Nothing will happen because you have differentiation with respect to x only. If you differentiate with respect to x, then the differentiation of e raised power x is e raised power x only. So this will come, and the value for x is equals to 0 and value for y is equals to pi by 2. Just calculate it with the help of calculator. You will get the answer as 0. Now next is fy, dou f by dou y. Then if you differentiate this, then what you will get, cos y differentiation in minus sin y. So minus sin y, and e raised power x is constant, so no need to worry about that. And put the value for x and y 0 and pi by 2. Calculate it with the help of calculator. You will get the result. So all the individual result you will be get by doing this partial differentiation, and then put the value in this equation. You will get a final result. Okay, so this is your final result. I hope this Taylor series expansion is clear to you all. Now let's move to the next important question. The question is, calculate the gradient given u is equals to yz by x, v is equals to xz by y, and w is equals to xy by z. You have to find the gradient only. Okay, for finding the gradient, very early I told you it's a matrix, so you have to solve the matrix. Okay, see, u v w is here, which further depends on x, y and z. Okay, so u v w depends on x, y and z. So take all the partial differentiation separately. Dou u by dou x, dou u by dou y, dou u by dou z, dou u by dou x, dou u by dou y, dou u by dou z. Okay, likewise you have to move. Okay, like this you have to move. Now dou v by dou x, dou v by dou y, and dou v by dou z. Then dou w by dou x, dou w by dou y, dou w by dou z. Okay, so this is the matrix you will get. Then find all the individual partial differentiation values and put this in this equation. You will get the answer. Okay, after getting the answer, you just simplify it by taking this row and this column and this row as constant, and just find the matrices by traditional method. You will get, okay, the final result. You will be getting 4. Now let's move to the next. This is the important question which might come in exam. Understanding the Jacobian in the context of data science. What is Jacobian? Jacobian can be given as matrices like this, which I have told you. So this is Jacobian with respect to matrices. In context of data science, Jacobian helps us to analyze how change in the input variables affect the output variables. So see, the change in input variable, how it can affect the output variable, this can be given as the Jacobian in data science. Okay, let's see the example. Cost of 3 notebook is 30 rupees, cost of 5 pens is 25 rupees, and cost of 5 notebook is 7 rupees. So how this cost of 5 notebook and 7 pen can be given as? See, for finding 5 notebook cost, first the 3 notebook cost is 30 rupees. So you will do 30 into 5 by 3 for finding the cost of 5 notebooks. Okay. For finding the cost of 7 pens, you will do similar, 25 into 7 by 5. Okay. Now to connect with Jacobian cost of 2n notebooks with 2c, cost of 1 notebook is 2c by n. Let's suppose the cost of 1 notebook is 2c by n, then cost of dn notebook is 2c by 2n dn. Okay. Similarly, the cost of dp pen is 2c by 2p dp. Okay. Here 2 notebook, now here 2 pen. So 2c by 2p dp plus final cost of final cost. So final cost will become dc is equals to 2c by 2n dn plus 2c by 2p dp, because 2c by 2n dn this one and 2c by 2p dp this two. So final cost will become dc is equals to 2c by 2n dn plus 2c by 2p dp. So if we set up with variable with column v and cost c, this matrices we will get as Jacobian. Okay, so dou w by 2n, dou w by 2p, dou w by 2x, dou u by 2n, no, it's v. So dou v by 2n, dou v by 2p, dou v by 2x, likewise dou u by 2n, dou u by 2p, and dou u by 2x. So same you have to write in an exam if this question appears. I hope this module is clear to you all. Okay. So this was a simple module. I hope all the concept is now cleared. Okay. Now I will attach this PDF in the description. You just see once and just study these all questions. Okay. Till then, bye bye.